Okay, I'm going to be working through the next homework section, which is 7.1. And make sure I mark these off. I've done that. All right, so 7.1, we're going to look at number 13. So number 13, we're going to draw this angle 135 degrees. So we can basically break up our major angles. Here's 45, here's 90. Add another 45, we'll be at 135. So the angle measure here is 135 degrees, and there's a ray that extends out in that direction. All right, next one, 17. 3 pi over 4. I'm going to write 3/4 pi. It's the same thing. So here we can break up our plane and looking at multiples of pi over 4. So pi over 4 is here. That's pi over 4. Here's 2 pi over 4, and then 3 pi over 4 would actually be the same exact thing that we just had. Same as 135 degrees. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Next, 19, negative pi over 6. All right, so pi over 6 is equivalent to 30 degrees. So if we look at splitting up, here's 30, 60, 90. So this is pi over 3. Here's 2 pi over 3. And then we have 3 pi over 3. 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, and then 12 pi over 3. So what we need here is, I said 3, sorry, 6 is what I meant to say here, 6. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Sorry. So now we start here, and then now we're going to go negative. So it's going to be a clockwise rotation by pi over 6, which puts us here. And let's see here, number 23. All right, convert each angle into radians and express it as a multiple of pi. So 30 degrees. Number 23. 30 degrees. So the way we convert is we multiply it by pi over 180, and then 180 degrees, and then we can reduce this. 30 goes into 30 one time, and then 30 goes into 186 times. And so what you get is pi over 6, or you could say 1/6 pi. We usually do this, but it's the same thing. 25, 240 degrees. 240 degrees, same exact thing. Multiply by pi, divide by 180. So what number goes into both of those? Let's first of all, let's see, we'll rewrite this. Let's just divide by 10. So you have 24 times pi over 18. So what goes into both 18 and to 24? How about 6? 6 goes into 24 4 times, and 6 goes into 18 3 times, and the degrees cancel. So you get 4 pi over 3, or you could say 4/3 pi. Okay, that is number 25. Number 29, 180 degrees. So this one's going to be pretty straightforward. 180 degrees. And the 180s just cancel out. So that's pi. So of course, 180 degrees is equivalent to pi. Now, 31, negative 135 degrees. Negative 135 degrees. So we need to find something that goes into both of these. All right, so how about, I mean, you can start with pretty much anything you want. 5 goes into both of those, right? 10 doesn't. So 5 goes into this, let's see, I can't do my simple math right now. 5 goes into this 27 times. So minus 27, and then pi, and then over. 5 goes into this 36 times. And then now it's a little easier to see 9 goes into both of those. Goes into this one 3 times, so negative 3 pi, and 9 goes into this 4 times, so negative 3 pi over 4. Telling you, arithmetic, I do not enjoy. 37. This time we're converting the other way. Negative 5 pi over 4. 37. Negative 5 pi over 4 into degrees. So we're going to, this time, multiply by 180 degrees, divide by pi. So it's the flip of this. The pi's cancel. And then we have to do, let's see if we can reduce this at all. Let's see, does 4 go into 18? 620? Yes, it does. So we have negative 5 out front, and then 4 goes into this. Let's see, 4 with 20 left over, 45. So 45 degrees. I keep the degrees here, and then 45 times 5 is going to be 225. So negative 225 degrees. All right, next one. 45, negative pi over 6. I'm going to multiply by 180 and divide by pi. Pi's cancel. And we still have a negative out there, and then 6 goes into this 30 times, so 30 degrees. Negative 30. 45. Okay, 49. Okay, convert each angle in degrees to radians. Express your answer in decimal form. So negative 40 degrees. This is number 49. Negative 40 degrees. Now I'm going to convert to radians, so I'm going to go pi, and then over 180. And I'm going to need my calculator here. And so because this is not a common angle, well, hold on. Express it in decimal form, round. Okay, so they want it in decimal form, so that means I don't want it with the pi in there. So I'm just going to do negative 40 times pi. So 40 times pi is about 3.145. So I get something like negative 125.66 over 180. And the degrees I just canceled out. So divide that by 180. I get approximately negative 0.698. They want us to round 2 decimal places, approximately negative 0.70. So the only difference between this and the one before is the one before they said express it as a multiple of pi. So we were putting answers like 3 pi over 4. Here they want it as a decimal, so we want to actually turn pi into about 3.1415 and multiply it out and get a decimal. All right, number 49 is done. 53. Convert the radian measure to degrees, so 3.14. This is 53. 3.14 This is in radians, so I want to go to degrees. So I multiply by 180 degrees, I divide by pi. Again, what I'm going to do is just take 3.14 times 180, which is approximately 565.2, and I'm going to leave the degrees there, and then divide that by pi. And I get approximately 179.91 degrees. Next one, 53, 61. 50 degrees, 14 minutes, 20 seconds. All right, so here's what we're going to do. We're going to take 50 degrees plus, we're going to take the minutes, 14, divided by 60, and that'll convert it to degrees, and then plus the 20, and we're going to divide this by 3,600. And so we're going to say minutes here, 60 minutes, and then seconds there. So this is 50 degrees plus 14 divided by 60 is about 0.2333, it goes forever, plus 20 divided by 3,600 is 0.00555. I'm going to add all these up, and these are now in degrees. So plus 0.233333 plus 50. So you get approximately 50.238, something like that. Just, you can come in. Degrees. 61. What's up?
Hey, no, sir.
Hey, how are you?
I'm Dan Wardle. I got you the semester online.
Uh-huh.
And just wanted face to face.
Okay.
I have a small question. I got a kind of a conflict on my schedule with the first exam number 2, which is I think October 27th.
Yes. sorry about that, 65. So for this one, we're going to want to go the other way. We're going to want to convert the degrees over to degrees, minutes, seconds. So what we're going to do first is we're going to take the 40 and we're going to say this is 0.32. We take the decimal 0.32, and the first thing we do is we multiply it times 60. So let's see what we get here. So 0.32 times 60, we get 19.2. So that means we have 40 degrees, we have 19 minutes. So we're taking the whole number here, and then this decimal, we're going to work the next part. So we're going to take the 0.2 and multiply that times 3,600. So 0.2 times 3,600. Oh, this is obvious, 720. Okay, so you get 720 seconds. Now, let me see the 65. Let me check something here. 7-2, 7-1. What? What number was this? 19. Did I do something? Oh, I know what I did. Oops. Oops, oops, oops. I knew that didn't look right. This is not 3,600. This was 60. Oops. We've already converted to minutes. So to go from minutes to seconds, we just multiply by another 60. That is my fault. So that's just going to be 12. So this is 12 seconds. Yeah, okay, sorry. You can only, these two numbers have to be between 0 and 60. So brain fart, sorry. All right, 71. 71 through 85 odd. So 71, S denotes the length of the arc of the circle, R is the radius, and theta is the angle. Find the missing quantity. So in 71, they give you R is 10 meters, and they give you that theta is half a radian. And we're using the formula S equals R theta, but remembering that theta has to be in radians here. So this is going to be pretty straightforward. The missing quantity is S. So S equals R, which is 10, and then times a half. So we're going to get 10 meters times half. Let me put meters there. So we're going to get 5 meters. So if you have a radius of 10 and you swing through an arc of half a radian, then the measure of this side, this arc, will be 5 meters. This half a radian. Okay. Next one, 73. Theta is 1/3 radians, and S is 2 feet. Two feet. Theta is 1/3 radians. So we're missing the R here. So we're going to solve for R. So to solve for R, let me just solve for R here. R would be S over theta. And let me go ahead and solve for theta also. Theta would be S over R. So those are the 3 different equations we could have. Here we're solving for R, so R will be S, which is 2 feet over 1/3 radians. We don't need to put the 1/3. This will be 6 feet. So just flip it up, multiply. 3 times 2 is 6. 75. R is 5 miles, S is 3 miles. R is 5 miles, S is 3 miles. And so we're trying to figure out what theta is here. So theta is S over R. And this is miles and miles, so the miles are going to cancel. And you get 3/5 radians because it's a measurement of an angle. So 3/5 radians. 77. R is 2 inches. Theta is 30 degrees. R is 2 inches. Theta is 30 degrees. All right, so we have to be careful here. We're trying to get S, but for the formula S is R theta, theta has to be in radians. So we first have to convert this. So we're going to multiply by pi over 180, and then cancel that out. That's going to be pi over 6. So S is going to be R, 2 inches, times pi over 6. And that's just pi over 3 inches. But we probably want this as a decimal. So 1.047, 1.047 inches, approximately. All right, 79. Now we want to know an area, so we're going to be using the formula, different formula for 79. We're going to use the area is 1/2 r squared theta. Again, theta has to be in radians. And they give us here that r is 10 meters and theta is 1/2 radians. R is 10 meters and theta is 1/2 radians. So what's the area? So the area is 1/2 r, which is 10 squared, times theta, which is 1/2 radians. Now this is meters, just remember. So we square the 10 first, that's 100. Half of 100 is 50, and half of that is 25. So we get 25 square feet because it's a measurement of area. Number 81, 1/3 radians, and the area is 2 square feet. So 1/3 radians is given. This is for 81. And we're given that the area is 2 square feet. So what I'm going to do is use this formula again. This time I'm not going to solve for r theta. I'm just going to use the formula, not S, sorry, A. So the left side of the equation becomes 2 equals 1/2. R we don't know, so r squared, and then theta, which is 1/3. So we're going to solve for r now. So 1/3 times 1/2 is 1/6. So we get 1/6 r squared. We're going to multiply both sides by 6. So we get 12 is r squared, and then we're going to take the square root. So root 12 is equal to r. I'm only going to take the positive root because it's a radius, so we're going to have positive answer. So root 12, that's approximately 3.464. And this is in feet, approximately 3.464 feet, because it's a radius, measurement is feet, because it was feet squared for area. Okay, 83. R is 5 miles, area is 3 square miles. Area is 3 miles squared. Same formula, so the left side is 3 equals 1/2. The radius we know is miles, so 5 miles squared, and then times theta, which we don't know. So now I'm going to take 5 and square it, 25. Half of 25 is 12.5 theta, and then divide through by 12.5. And we're going to get about 0.24 radians. That's theta. So it's just plugging stuff in, that's all we're doing. Number 85. R is 2 inches, theta is 30. R is 2 inches, I'm gonna write it like that. Theta is 30 degrees. We've got to convert that over. So times pi over 180. This is pi over 6. And now I can use the formula because I have to be in radians. So area is 1/2 r, which is 2 squared, times theta, which is pi over 6. Let's see, this is 4. Half of 4 is 2. So we get 2 times pi over 6. So the area is, reducing this, pi over 3, square inches. So I'm putting inches squared. And as a decimal, 1.047. 1.047 square inches is our area. All right, pretty straightforward here so far. 89, find the lengths in the area A. Oh, sorry, find the length S in the area A, and they give you a picture. So you got $12 yards. You've got 70 degrees. The S here is this length, and the area is the inside. So remember, S is r theta. Here, S is r, which is 12 yards, times theta is 70 degrees, but we have to convert it. So 70 times pi over 180. And I'll just do that on my calculator. 70 times pi divided by 180. So this is approximately 1.221 radians. So that goes here, 1.221 radians. And we multiply times 12, and we get approximately 14.66. And this is an arc length. So it's going to be measured in the same unit we were measuring the radius in, so yards. And then the area is 1/2 times the radius, which is 12 squared, times the angle, which has to be in radians, 1.221. So I'll do that on my calculator. Square that, 144, half of 144, and then times 1.221. So it's approximately 87.91 squared yards, because it's a measurement of area. All right, 95 through 103 odd. So some word problems. A water sprinkler sprays water over a distance of 30 feet while rotating through an angle of 135 degrees. What's the area it waters? So you have a 30-foot spray pattern. That's how far out it goes. And it rotates through an angle of 135 degrees. All right. So what we first need to do is convert that. We want to know the area, right? This area in here. So the area is half of the radius squared times theta. We need theta to be in radians. So 135 degrees times pi over 180. And that'll be our theta. Let's get that as a decimal. 135 times pi divided by 180 is approximately 2.356 radians. So I should be able to plug in here 1/2, got 35 squared times 2.356. getting approximately 1443.13. And this was measured in feet, and this is an area, so square feet. Something is off here. Oh, oops. I put 35 feet in the problem, it's 30 feet. So I have the wrong answer because I put 35 instead of 30. So it's done the same way, just replace that with 30. The correct answer should be 1,060.29 square feet. Okay, 97. The arm of a blade of a windshield wiper has a total length of 34 inches. The blade is 25 inches long and the wiper sweeps at an angle of 120. How much window area can the blade clean? Okay, so this is a little bit different. You have a windshield wiper where the arm is 34 inches long. So from here, it's 34 inches long. But the blade, the part that actually touches the window, is only 24 inches long. So this part of the blade is the part that has the wiper on it. This is only 24 inches. And so it rotates, and it rotates through an angle of 120 degrees. So 120 degrees somewhere over here. When it sweeps out like this, the blue part, which is the blade, only sweeps out this area in here. It does not do this. So what we need to do to figure out the area that's swept out is we need to actually figure out the whole area first for the whole arm, and then subtract this smaller piece. Now remember, this right here is 10 inches, because if it's 34 and the wiper blade's only 24, then that has to be 10. So let's say the total area we're looking for, okay, is going to be the area of the whole thing, which would be this, 34 swept out. It would be this thing right here. That's the whole thing. We'll call that area 1. And then you subtract from that, so I'll say minus this smaller one here, which is only 10 swept out like that. So we'll call that A2. So A, what we're looking for is A1 minus A2. So what's the area of A1? It's half 34 squared times, it was 120 degrees, which we have to convert. So we multiply by pi and divide by 180. So 1. It's about 2.094. That's how many radians we have. So I'm going to go 2.094 here. That's the area of A1. Area of A2 is 1/2 10 squared times the same angle, 2.094. And when you do that and subtract the 2, you should get about 1,125.74, and this was inches, so inches squared. Okay, I'm getting close, but I'm running out of time here. Motion on a circle. An object is traveling on a circle with a radius of 5 centimeters. An object is traveling on a circle with a radius of 5 centimeters. 5 centimeters. Some object is moving along this circle. If in 20 seconds a central angle of 1/3 radians is swept out, so in 20 seconds, an angle of 1/3 radians is swept out, what is the angular speed of the object, and then what is its linear speed. So we want to know what is the angular speed, that's omega, and what is omega, and then what is the linear speed, which we call v. So those are the two questions. All right, so we have formulas for these in the book. Omega is theta over time. The angle over the time. And then our linear speed, there's actually two formulas for it, but the one that we like to use is this one here, r omega. And that's because we know what r is and we know what omega is. We're going to calculate omega first. So the theta, what is the angle we sweep out? Well, we sweep out an angle of 1/3 radians. And how long does it take us to do that? 20 seconds. So the angular speed, if we look at these as fractions and flip, is 1/60th radians per, and what was it? Seconds per second. That was our angular speed. We're going 1/60th of a radian every second. And then the velocity is going to be the radius, which is 5 centimeters, times omega, which is 1/60 radians per second. And that means our velocity, 5/60, 5 goes into 60 12 times. So that'll be 1/12 of a centimeter per second. And remember that we don't have to put the radians in here when we're writing velocity. So if we do 5 centimeters in 1/60th of a second, then that means we do 1/12 of a centimeter every second. All right. Now, what am I on? 101. A gondola on an amusement park ride similar to the spin cycle at Silverwood Theme Park spins at a speed of 13 revolutions per minute. I'm going to run out of time. So some ride spins at 13 revolutions per minute. All right. If the gondola is 25 feet from the ride center, 25 feet from the ride center, what is the linear speed of the gondola in miles per hour? Find the linear speed in miles per hour. All right, so linear speed, we need r omega, right? R omega. And omega is our angular speed. Now this is our angular speed, but they've given it to us in a way, we need it to be in like radians per minute, and right now it's in revolutions per minute. So remember that one revolution is 360 degrees, which is the same as 2 pi radians. So we do 13 revolutions every 1 minute, and we multiply by 2 pi radians for every 1 revolution. And then the revolution cancels, and we get, what is that, 26 pi radians per minute. Okay, this is our omega. It's our angular speed. Man, I'm sloppy today. So our omega is that. Now, to get our velocity, linear speed, we need r times omega. And so our velocity is 25 feet times 26 pi radians per minute. And the radians we can ignore because we're getting a speed here. So 26 times 25 times pi. I'm going to multiply all those together. 25 times 26 times pi. So I'm getting 2,041.975 feet per minute. So I'm going to say for every 1 minute. Now that is a speed, but it's measured in feet per minute. We need it in miles per hour. So what I'm going to do now is first convert feet over to miles. So I put feet down here so it'll cancel. Put miles over here. 5,280 feet in every 1 mile. I also need my minutes to go to hours. So I put minutes up here so that they'll cancel, and then hours down here, and there are 60 minutes in every 1 hour. So now I'm just going to multiply across. Feet and minutes cancel. I'll have miles per hour when I'm done. So I'm going to take this number times 60. Okay, and then divide by 5280. So this is approximately 23.2 miles per hour. It's moving about 23 miles an hour. All right, 103. Last one. I think I might have just enough time to do this. A Blu-ray drive has a maximum speed of 10,000 revolutions per minute. 10,000 revolutions per minute. If the Blu-ray disc has a diameter of 12 centimeters, diameter, they almost caught us here. Diameter is all the way across, so the radius is actually 6 centimeters. What is the linear speed in kilometers per hour of a point 4 centimeters from the center of the disc if it is spinning at a rate of 8,000 revolutions per minute? Okay, you know what? Because of time, I only have 2 minutes. I'm going to let you mess with that, and then you can ask me questions on that in class. I think that's fair.